All right, so for starters, I got a few things on here that I mistakenly did not add to the Maya 5 notes. It's something that I had realized I needed to do last year. Didn't do it, so we're a little bleed over. So these are things that we discussed when we were doing the second half of the wagon. You might have had to soften some edges, right, for the wagon covering. You might have had to, or you definitely had to, reverse some faces on your wagon covering when they were showing the black side of the normal. So just formalizing those in the notes so you have a place to find them. And as a reminder for the video, let me just go ahead and throw some things in here. So if I took this object and I hardened the edges, it would look very jagged, right? If I soften my edges here, you'll see the shading gets broken because it doesn't know what to do with this down here. So if I take this face and I harden this, then it'll figure it out, sort of. Although this vertice up here, it's not very happy that it's soft, but whatever. So anyway, that's all that stuff. And then reverse was obviously what we needed to do to fix them if they show as black. Black just means that that is not the direction the normal is facing. Your objects should have normals facing outwards. More on that if you become pro. So normals and all that good stuff, advanced discussion, we don't need to go there. Basically just remember the one-sided piece of paper concept. So, okay, let's get into the new stuff. So we're going to start off with discussing the poly count. And what is the poly count? Why do we need to use it? So the poly count does exactly what it says in the name. Counts your polygons. It also counts the components that make up those polygons. So your faces are made up of a certain amount of edges. The edges are made up of vertices, right? So counts them all up for you. Now, this is a good way, and in fact, before I move forward, so to activate this is one of those things where if I come by to answer your question on something going forward and I don't see the poly count on your screen, the first question I will ask you is, where's your poly count? Because that is going to be a leading indicator on some of the things that you might be able to catch why they're going wrong. So the poly count is turned on under display, heads up display, poly count, and it should be checked. So, and you can see it's got a whole bunch of numbers here. I'll just add a random torus. Boom, it's telling me this torus is made up of 400 vertices, 400 faces, 800 edges. Cool. So that way if I select any face on here, I'll know, hey, okay, I got these two faces selected. They're made up of 4 tries. Okay, sure. So let's go ahead and open up now. So this is what we'll be working with today. So first thing on here, many people have already ran afoul of this. When you want to delete an edge, you need to delete all of the edge. So when you do an edge deletion, you need to use this keyboard shortcut, Command Delete, or you can find Delete Edge Vertex under Edit Mesh. And so I've already seen this several times on people's work, but it's not been a problem until now. So if I double click this loop here, I backspace, the shape of this didn't change, right? You can still see it goes boom and then boom. It doesn't just go straight to the next edge loop. That's because these vertices didn't go anywhere. I deleted the edges. I didn't delete the verts. And that's because Maya assumes that I want them there. Like they're there for a reason. I deleted only the edge and not the vertices because I planned to use the verts for something else. Now, if I go through, I can click on them and delete them, and you'll see now it goes straight down. So the real way to delete this would be if you select this edge loop, hold down Command, delete, and it goes away. Now, doing that improperly, right? If I just delete this, my vertice count didn't go down. It still says 121 vertices. But if I do it right, oops, if I do it right, 101 vertices. Great. I know it went right. So sometimes you might have to do some simple off the top of the head math. I know this is a 20-sided object because default cylinders are 20-sided objects by default, so I didn't change anything with it. So 20 vertices going away makes perfect sense. Now, the other thing is merging vertices. It's all well and good if you want to delete vertices, but if you want to combine them, it's not mesh combine. I often have people in the first couple of weeks trying to do that. Mesh combine does not combine vertices. So if you wanted to merge these, let me select this group here, and I go to just edit mesh merge, nothing is going to happen. So merge, typical merge, it looks for neighbors that are too close to one another, and then it will merge them. So see how it has a little distance threshold? That's how far it's willing to look around a vertice to see if there's something next to it to merge. So now I'll go in, let me zoom in here. I'm going to grab Insert Edge Loop tool. Let me put one hella close to this edge here. So now if I go into my vertexes, so I got 141 verts on this object. Whoops, I didn't drag that right. I got 80 vertices selected, 4 concentric rings of 20. Makes perfect mathematical sense. Now if I go to merge, boom. Now down to 60 selected, back down to 121. We're all good. So my merge was successful. So that's oftentimes going to be your indicator on certain things, if you're good at quick maths. There's one more vertice than I expected at the end of this. Something somewhere didn't merge, and you can go around and look for it. So that's why the poly count is so useful to us. There's one of the questions on the bottom. What's up?
I had a question about the delete edge vertex.
Yeah.
Is there any situation where you would want to keep the vertices?
Yes, if you're planning on using multi-cut to like reconnect them, things along those lines, or if you need, say, of that whole ring that I was deleting, if I even wanted just half of those vertices, I wouldn't want to delete all 20 of them. Yeah. I would just manually delete the other 10. So yeah. So, like 99 times out of 100, no, there is no reason. Yeah. So, on the other hand, folks, if merge is always looking for neighbors, merge to center doesn't care. Merge to center just says, whatever you got selected, we're going to crash them all into each other in the middle. So if I select all these, edit mesh, merge to center, boom, it's collapsed. So your mileage will vary with merge to center. Be careful with it. It's typically good if you have two like little verts that are a little close and you want to just get them mathematically merged up. What am I doing here? There we mesh tools, insert edge loop. Right, so if I had something like this here, I could just select these two. Whoops, not reuse insert edge loop tool. Okay, reselect these. I could do something like that. And then folks, this is where your repeat last comes into play. So boom, G, repeat last. And here's another thing, folks. You'll notice that I have my move tool on. Why would I have my tool active? So I'm going to try and make a selection here. And see how my selection, my manipulator's pivot point is sort of in a weird spot? That's my way of knowing, oops, I selected something on the other side. So especially when you're trying to do merges, excuse me, it's always good to have move or scale active because they're the least obtrusive manipulators to be in your way. And then you'll know if you accidentally select a little too much. Oh, my manipulator's in a weird spot. Oh, okay. Deselect. Oops, except I didn't hold the right key. Control. There we go. So that's merge and merge to center. So, for review, why do we use polycount? To check our work. That's the shorthand of this. Polycount is for you to check your work. You are a tool operator, okay? You got to be smarter than the tools you use. How are merge and merge to center different? Merge looks before it crosses. Merge to center, just crashing in, just going for it. And they calculate to the volumetric center, so they just figure out where the center of the vertices you have selected. Okay, so let's actually cover the coursework for today. So let's bring this back to starts. So 2 aspects of this assignment, okay? And you gotta get them both right for the points. Let's start with the easy one. So here I'm showing you how to do a star weld. Here you have 2 objects. One thing that I did not mention about merge, to the point about people asking you to use combine for merging. You gotta merge vertices of the same object. If they're not the same object, they can't be merged together. So I could move this vertice from here out to here, and if I could even put this object in vertex mode and select both those vertexes, and you can see in my poly count I have 2 vertices selected, but if I try and merge them, nothing's going to happen. Still got 2 vertices, even though they're touching. So again, the point of that is that first thing you're going to do for these 2 is make them 1. Combine, then we can start the fun stuff. So the point is to connect this round cylinder to this square hole. How would we do so? You're going to take the base of this, and this is where I would say please don't just start dragging these vertices directly. Please create a new extrude. Then you can just scale it out. Now I got some extra faces there. Cool. Now I can just take these one by one. So I'm on my move tool. V is in vertex for snap. Snap to there. 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 There we go.
I don't even know what I was thinking. I was trying to think about how to do it, and then I was like, I haven't done this in so long that I was like, oh, this is just smarter. This is why you get the big bucks.
That's why I'm Teacher of the Year, baby.
Sorry. Wait, actually?
Yeah, I won Teacher of the Year 2 years ago.
Oh, sick.
Actually,
I think I was there for... No, never mind.
It was the year after you graduated.
Yeah. I was there for the ROP dinner. That was a fun time.
Oh, it's so funny. Actually, I'm recording this, so it's not very funny. I'm going to say nothing and remind me about this point that I was making when I'm done recording. Because then it will be funny.
You mean that one time where that one student...
No. So, now you can see why I called it a star weld. So that is how all of those things will snap together, right? All those little triangles going out, and then you got some trapezoids here, 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 here. So now when you're all done, now we can just... Come on, Maya. There we go. Now you can just select all this stuff. I have 166 verts on this thing. Edit mesh. Merge. 123. Boom. Perfect. Seamless. So that is the first part. So that is vertice welding right there, folks. Drag a vert over it to snap to another vert. Select them. Merge them. Boom. Welded together. Let's weld together a Rubik's Cube. So this is a very messy plate here. There's a lot of extra edges that were useful for when I was making this object, but have served their usefulness. Again, this is, tomorrow's notes, but I'll flip over to this. This concept is serving the end result, which is retopology, making the cleanest, most succinct arrangement, best way of making your model using the least amount of things, essentially. So, coming back to this is a little too noisy. A lot of extra vertices we don't need. So, first things first. Yes, this is going to be very tedious. You're going to select all these unnecessary loops. I'm just shift double clicking on them to select them. Command delete. And then I'm going to go through all of these. Believe it or not, I know. This is the hardest, most insane thing a teacher has ever asked you to do.
No, I think reading is actually...
Yeah. So true. Too true. I have already warned them that that's coming and how everyone always hates it.
It's not even that bad. I just always like making fun of you for it. And I'm making fun of you.
Yeah, I know. It's not bad. It's just like everyone goes out of their way to make it difficult on me by not doing it. And okay, so there, boom. We've deleted all of the extra edges. Now we got a nice, clean looking side of a Rubik's Cube. Cool. So now we're gonna start moving this around and slapping these pieces together. So let me start by getting one duplicate off to the side. And then this is going to start and serve as my bottom. Number one mistake people will make. People are going to make this mistake, so let me warn you right now. Start by flipping this over so that your grooves are facing outward towards the bottom. Oops, that's the wrong rotate. I thought it was in rotate X. There we go. So yeah, because otherwise you're going to build with the grooves facing out towards the bottom, and then you'll be able to see inside your Rubik's Cube. Okay, so now that's facing down. Now I have this one. I'm going to move my pivot point to a corner. Bring this over here. Snap to that corner. Rotate tool. Yoink. This is rotate Z. We'll go 90 there.
Isn't there like a quick snap for the rotate?
You can turn on step snap for rotate, but I don't remember what the keyboard shortcut is.
I think like control something or shift something. But I don't know.
All right, snapping the next one over. Same concept. Rotate it this way. It's telling me 90 on the X. Sure. One more time. Duplicate. Move tool. Holding V as in vertex for snap to vertex. Rotate. It's going now 180. Duplicate one more time. Hold V for snap to vertex. This will be 270. And then, guess we'll just duplicate this bad boy. Zero it out. Pivot point, whoops. Pivot point to the corner. Hold V as in vertex. And there you go. Except it's not done yet. So these are all still separate. So then you'll select them all, mesh, and combine. Then, still not done. Vertex mode. I have 408 vertices at this stage. Edit mesh, merge, 296. And you'll also know if you did it right. If you press 3, it'll look very mushy. Okay? So if you have hard edges here, in fact, let me go back to before I merge all of these. Okay, so I undid my merge. It's still one combined object, but you'll see if I press 3, the corners don't mush up because they're not connected.
I was about to say it looks the same.
Yeah, it looks mostly the same, yeah. So again, final step is make sure, select all the verts, merge. So your Rubik's Cube should end up 296 vertices. This should end up with 146 vertices. Bingo. Unlike most assignments I give, folks, there is a discrete, correct answer for these. You either have the correct answer or you do not. So, final step on the Rubik's Cube, make it pretty. So, you're going to take these 9 faces on one side, go one side at a time. We'll assign our favorite material. I'll choose a blend. And whoops, I'm going to material attributes. I don't care what colors you choose for your Rubik's Cube, but 6 different colors. Why am I making you do this also, the coloring part? Remember back to where we started with this thing. There was 49 faces on each of these areas where this one face is. So this is very easy to do comparatively to when we started with this object. You'd have had to select 49 times 9 times 6, whatever that number is. So you're welcome, is what I'm saying. So, okay, so that is the assignment, folks. Just some simple moving, snapping, vert welding. So that's that. I'm going to stop recording.